Hello all, welcome to Creative Semicon self-paced learning videos. Now, in this particular session, we are going to discuss about Karnaugh map or KMAP. So basically, in an invariable KMAP, there are 2 power n cells, and each cell on the map represents a min term in the case of SOP form of representation and max terms in the case of POS form of representation. Now, in the case of your SOP expression, we assign min terms, that is product terms, to each cell of the KMAP. On the other hand, in the case of your POS form of representation, we assign max terms. For example, let's say if our n is equal to 2, that is nothing but for a 2 variable KMAP, you are going to have 2 power 2, that is 4 number of min terms and 4 number of max terms. That is total we are going to have 4 number of cells. Okay, so this is how your 2 variable KMAP is going to look like, where we are going to have the cells 0, 1, 2 and 3. Okay, now A and B are our variables and this 0, 1, 2, 3 are our midterms. Okay, so this is how we are going to build a simple 2 variable KMAP. Now, so this is my midterm A bar, B bar, A bar, B, A, B bar, A, B. In the case of my SOP form of representation, I'm going to write down midterms. And in the case of max terms, I'm going to write down my, in the case of my POS form of representation, I'm going to write down my max terms. So this is my first max term, A plus B bar, A bar plus B, and A bar plus B bar. Now, let's say if I'm going to have a simple 2 variable KMAP like this, f of A comma B is equal to sigma m of 0, 1 and 3. Okay, now, and I'm also going to have f of A comma B as pi m of 1, 2 and 3. So let us draw the K-map for this. So for a 2 variable K-map, I have 4 number of cells in both SOP and POS form of representation. Now, this is my A and B bar and B, A bar and A. 0, 1, 2 and 3. 0, 1, 2 and 3. A, B. Here I am going to write B and B bar, A and A bar. Or else you can write down 0, 1, 0, 1 and here also 0, 1, 0, 1. Okay. Now, I'm going to fill ones in the cell which we have given, that is min terms I'm going to represent it by 1. Okay, 0, 1, 3. And here 1, 2, 3. I'm filling it by max terms. Now, if I'm going to group this 2 and this 2, I need to group adjacent cells for solving my KMAP. Now, the common thing here is A bar, so I'm going to write down plus B. So the expression, the solved expression is nothing but A bar plus B. And here I'm going to group this 2 and this 2. So the expression, the solved expression is nothing but A bar plus A bar dot B bar. Okay. So this is the expression which we are going to get. So this is how we are going to solve our KMAPs. Now, let's say if I'm going to have a 3 variable KMAP, let us try to understand how to solve your 3 variable KMAP. Let's say here I'm going to have f of A comma B comma C as sigma m of 0, 1, 3, 7 and same f of A comma B comma C as pi m of 0, 1, 3 and 7. Okay. Now, so this is how my 3 variable KMAP is going to look like. So I'm going to have total 8 number of cells and here also I'm going to have total 8 number of cells. So this is my A, B, C, B bar, C bar, B bar, C, BC and BC bar, A bar and A. Here also I'm going to write down A bar and A, B bar, C bar, B bar, C, BC and BC bar and A and BC. So this is nothing but my 0, 0, 0, 1, 1, 1 and 1, 0. This is 0 and 1. Here, this is Let me change them. So it is nothing but BC. 0, 0 is represented by BC, or sorry, B plus C. Okay. And 0, 1 is represented as B plus C bar, and 1, 1 is represented as B bar plus C bar, and 1, 0 is represented with B bar plus C. And this is 0, A, and A bar. Okay. Now we will fill the midterms over here: 0, 1, 3, 2, 4, 5, 7, 6. These are the cell numbers, these are common. Okay. Now this cell is nothing but 0, so I'm going to fill it with midterms 1, 0, 1, 3, and 7. 0, 1, 3, and 7. Okay. Now what I can do, I can group the adjacent cells like this. These are the two grouping, two adjacent cell grouping, and here also I can group this adjacent cells. Now here I am going to get, so the two cells is going to have A bar as common and B bar as common. Plus in the two cells we are going to have A bar as common and C as common, plus BC. So this is the solved expression which we are going to have when we are solving this two variable KMAP. Now let's say if I want to solve this, then what is the expression, what is the common term which is present here? It is nothing but A, and in the both terms B is common, so I'm going to write down B. A plus B into, and in these two terms A is common again, and C bar is common, so A plus C bar into, and what is the common term in this two is nothing but B bar plus C bar. So this is how we are going to solve a two variable, three variable KMAP if we are going to have a function like this. Now let's take a four variable KMAP and let us try to solve it. So let's say if I'm going to have a four variable KMAP like this: f of a comma b comma c comma d is equal to sigma m of 1, 2, 4, 7, 11, and 13. Same in the case of my POS form: f of a comma b comma c comma d is equal to pi m of 1, 2, 4, 7, 11, 13. Okay. So for a four variable KMAP, I'm going to have total how many cells? 16 number of cells like this. And here also I'm going to have total 16 number of cells. Okay. Now, so this is nothing but my EB, CD, C bar, D bar, C bar, D, CD, and CD bar. This is nothing but C plus D, C plus D bar, C bar plus D bar, and C plus D. Okay, C bar plus D. And this is nothing but my A bar, B bar, A bar, B, AB, and AB bar. So I'm going to get A plus B, A plus B bar, A bar plus B bar, and A bar plus B. Right? Now, I'm going to note down my cell number: 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, and 14. 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, and 14. So 1, 2, 4, 7, 11, 13. Let me mark them: 1, 2, 4, 7, 11, and 13. Okay. So I can see from nowhere I can group them anything, right? So it is individual grouping like this. There is no adjacent pair at all, right? So what are the common terms which we are going to get starting from here is nothing but A B bar C D plus A B C bar D plus A bar B C D plus A bar B bar C bar D. A bar B bar C bar D. Okay. And on the right hand side I can see here I'm going to get the terms, I'm going to mark them 0, 0, 0, 0, 0 and 0, right? So if I group them, then what I'm going to get is simply, what is the common term over here? A bar plus B plus C bar plus D bar into, and I'm going to write down this A bar plus B bar plus C plus D bar, so on. Okay, so this is how I'm going to solve my 4 variable KMAP. Now, let us try to understand how to solve a 5 variable KMAP. Let's say if I'm going to have A, B, C, D, E as sigma m 0, 1, 3, 15, 17, 18 and 20. This is my midterm. Now, in the case of your 5 variable K-map, you are going to assume 2 4 variable K-maps. You can assume this as placed on one K-map placed on another K-map, like this you can assume that. Okay. So like this you can assume. And you are going to draw your 4 variable K-map. And this is B, C, D, and this is B, C, D. And for this whole K map, your A is common and you are going to keep it as 0. And for this whole K map, your A is equal to 1. Okay. Now it is D bar, E bar, D bar, E, D, E, and D, E bar. Same DE bar, DE, D bar E, and D bar E bar, and B bar C bar, B bar C, BC, and BC bar. 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, and 14, and 16, 17, 19, 18, 20, 21, 23, and 22, 24, 25, 27, and 26, 28, 29, 31, and 30. Okay. So let us fill them out. 0, 1, 3, 15, 17, 18, and 20. Okay. Now, if I want to make grouping, now how to make this grouping? So I can see over here, this term, this term and this term are adjacent to each other, because what I've told, assume one K-map placed on another K-map like this. So these two terms will be adjacent over one another, right? And what else we have adjacent? Yeah, nothing is adjacent, and these two are adjacent over each other, and these two are adjacent, right? And this is one term left out, this is also one term left out, and this is also one term left out. Now what is the expression you are going to write down? So what is the common term over here? If we group this two, then the common term here is B bar C bar, and the common is D bar into A bar is common, right? Plus this two, what is the common term here is B bar C bar, B bar C bar into D bar. Plus you can write down as it is, for the whole K-map A is common, and it is B bar C, A into B bar C into D bar E bar. So like this we are going to solve this 5 variable K-map and write down our Boolean expression. So that's about our 5 variable K-maps and introduction to K-maps. Thank you.